You should know that some objects in the cosmos wield magnetic fields so incredibly potent they can physically warp atoms and affect our world from thousands of light years away. We are about to delve into the nature of magnetars, which are extreme neutron stars packing unimaginable energy into a volume no larger than a city. This is an exploration to the very edge of matter, where a single outburst can make space and time themselves shudder. Magnetars represent a unique class of neutron star, yet they are so much more. What sets them apart is their unbelievably powerful magnetic field, which is millions of times stronger than any magnet you or I have ever encountered on Earth. This exceptional magnetic force not only makes them distinct from other neutron stars, but also grants them singular properties that deepen our grasp of the cosmos. So, why is studying them so vital for our comprehension of the universe? The importance of magnetars is rooted in their function as natural laboratories for extreme physics, offering you a direct view into the conditions found in the most obscure and enigmatic regions of space. By observing them, scientists can test the foundational principles of astrophysics and theoretical physics, from general relativity to quantum mechanics, and see how matter behaves under pressures we can never hope to create on Earth. Let's consider how a magnetar is born. The process begins when a truly massive star explodes, causing its core to collapse into a neutron star. Under just the right circumstances, this newly formed stellar remnant can generate a magnetic field of immense power, transforming it into a magnetar. This sequence is particularly compelling because it reveals how the demise of a star can give birth to one of the most extreme objects in existence. But the story doesn't end with a magnetar's creation. These objects are far from static. They are dynamic, highly active bodies whose magnetic fields not only possess incredible strength, but also evolve over time. This evolution can unleash spectacular events like gamma-ray bursts, which are so ferociously bright that you can detect them from billions of light years away, giving us vital clues about the inner workings of these bizarre celestial objects. When you contemplate the magnetic field of a magnetar, you are considering a force of truly cosmic proportions. To give you a sense of its scale, if you were to get too close, its magnetic pull would instantly crush any object. Think of a simple refrigerator magnet, then amplify its power to an astronomical level. This field is so dominant that it influences its own structure and all surrounding matter, cultivating an environment completely inhospitable to any form of life. The activity of these objects also includes the emission of X-ray pulses, which act like signals sent across the immense emptiness of space. These regular flashes are a direct consequence of their swift rotation, combined with intense magnetic phenomena. Each pulse carries a story about the internal composition of these cosmic behemoths, presenting a complex code that we are only now starting to unravel. While magnetars are profoundly fascinating, they are equally terrifying. The sheer energy they release can shape the formation of new stars and even entire galaxies, elevating their cosmic role to a level of significance we can scarcely comprehend. In this way, each magnetar can serve as a catalyst for stellar creation, reminding you that in the universe, destruction and new life are fundamentally intertwined. As our exploration of magnetars continues, we find they are also linked to gravitational waves, which are the ripples in space-time that Einstein first predicted. The relationship between magnetars and these ripples is a frontier of active research, one that holds the potential to completely reshape our understanding of gravity and the fundamental fabric of the universe. Popular culture has started to take notice of these cosmic wonders. You can now find references to magnetars in films, novels, and science fiction, although these depictions often lean more toward fantasy than scientific fact. This trend brings up interesting questions about how society perceives such objects, and the way these cultural portrayals can shape our collective grasp of scientific concepts. As we investigate the world of magnetars more deeply, it's crucial for you to appreciate the immense challenges that scientists must confront. Observing these objects is an incredibly difficult endeavor. The vast distances involved, the overwhelming intensity of their magnetic fields, and their often transient nature are just a few of the hurdles to overcome. Yet, every breakthrough in this field moves us one step closer to solving the great puzzles of the cosmos. Ultimately, the quest to understand magnetars is a search for pure knowledge. You and I are left to wonder what they can reveal about the cycles of life, death, and the evolution of everything around us. Every fact we learn about these extreme cosmic magnets reinforces the idea that there is so much more to discover in the vast, mysterious universe we call home. With each new insight, we gain a clearer perspective on our own place in the cosmos and the intricate complexity of nature itself. So, what exactly are these fascinating yet enigmatic objects? I ask you to imagine a star whose power isn't just in its brilliant light, but in a magnetic field so immense it can inflict catastrophic damage on its cosmic neighborhood. Deep within a magnetar, an epic battle rages between gravity and magnetism, forging an object that defies our current understanding of physics and opens up a universe of compelling new questions. While a typical neutron star is the collapsed core left behind after a giant star goes supernova, a magnetar elevates this concept to an entirely new level. The key difference is its magnetic field, which can be 1,000 trillion times stronger than that of our own planet. To put that in perspective for you, if a magnetar were situated just 10,000 kilometers away, it would cause absolute chaos, disabling our electronics and rendering compasses useless. This isn't merely a strong magnetic field. It's a force of an altogether different magnitude. Now, how do these magnetic titans actually come into being? The process is initiated when a massive star depletes its nuclear fuel and succumbs to its own immense gravity, collapsing inward. It's important for you to remember, however, that this outcome isn't guaranteed. Not every neutron star is destined to become a magnetar. It is thought that magnetars are the product of a highly specific magnetization event that takes place during a supernova explosion. Under these conditions, the resulting magnetic fields can be amplified to extraordinary levels, creating what we now identify as a magnetar. But their physical nature is far more complex than just glowing spheres of neutrons. They possess an intricate internal structure where dense particles are clustered at their core, fostering an environment where physics operates in ways we are still working to comprehend. Think of a colossal magnet, but instead of a common object, it is a cosmic giant residing in the depths of space, emitting powerful energy pulses that travel across the universe. The identity of a magnetar is fundamentally tied to its magnetic field, which is not just strong, but what scientists classify as an extreme magnetic field. We can measure this incredible force by using X-ray telescopes, which detect the radiation these objects release and allow us to gauge its intensity. Through these observations, researchers have concluded that a magnetar's magnetic field is theoretically potent enough to distort the fabric of space and time around it. To help you visualize this, picture a magnet that pulls on metal with an astonishing force. Now, amplify that power to the point where it can physically bend everything in its surroundings. This is the level of influence magnetars command, and their reach extends well beyond their immediate presence, altering nearby matter from cosmic gas clouds to neighboring stars. When you delve into the topic of magnetars, it is impossible to ignore gamma-ray bursts, one of the most brilliant spectacles in the cosmos. These cataclysmic explosions appear as flashes of light so intense they can be observed from millions of light years away. They are thought to be directly linked to the activity of magnetars, and studying them not only deepens our knowledge of these objects, but also gives us clues about other catastrophic events unfolding across space. Did you know that in a matter of seconds, a single gamma-ray burst can emit more energy than our sun will in its entire lifetime? Another key characteristic of magnetars is their emission of X-ray pulses, which serve as a rhythmic beat from a cosmic heart, offering us a direct glimpse into the depths of these enigmatic objects. Each pulse carries invaluable data about the magnetar's structure and composition, assisting us in gradually uncovering their mysteries. But what these signals truly reveal is a snapshot of a magnetar's dynamic and violent life. Comparing a magnetar to a regular neutron star is like putting a finely tuned race car up against a standard family sedan. Although both are impressive feats of engineering in their own right, magnetars are in a class of their own because of their extreme magnetism and their capacity to produce mind-boggling cosmic phenomena. In this regard, magnetars act like the superheroes of the universe, performing feats that constantly challenge the limits of our scientific understanding. Their life story is just as captivating, from their violent birth in a supernova to their eventual fade into obscurity over thousands of years. Throughout their existence, their powerful magnetic activity and energetic outbursts actively contribute to the chemical and physical evolution of the cosmos. It is truly remarkable to think that such a potent and mysterious entity could arise from the death of a single, massive star. In the end, magnetars are much more than just a type of neutron star. They are the magnetic titans of our universe. Their incredible power, their deep mystery, and their profound impact on their surroundings remind us just how much we have yet to discover about the cosmos. As we continue to study these captivating objects, every new finding moves us one step closer to understanding the fundamental secrets of existence. So the next time you look up at the night sky, remember that somewhere out there, a distant magnetar might be unleashing its formidable energy, leaving its mark on the vast cosmic stage. Have you ever considered the true force of a magnet? I'm not talking about the small ones you have at home for holding notes on the refrigerator, but a cosmic magnet with enough power to alter matter light years away. This is the reality of magnetars, which are essentially stars that function as the universe's most extreme and powerful magnets. Just how extreme are their magnetic fields? The intensity is almost beyond comprehension. To give you some perspective, a common refrigerator magnet possesses a field of about 1 milligauss, while a magnetar can generate a field exceeding 1 billion gauss. This staggering difference is like comparing a gentle breeze to a cataclysmic hurricane, and its immense force has profound and often puzzling effects on the surrounding space. Measuring these incredible fields is far from a simple task. Astronomers employ advanced technology, utilizing telescopes capable of capturing electromagnetic radiation across the entire spectrum, from radio waves to X-rays. In much the same way a doctor uses a sophisticated scan to examine the human body, each pulse and emission from a magnetar allows scientists to uncover a little more about the structure and nature of these captivating objects. So, why is it so vital to understand the magnitude of these fields? The answer is found in the way they interact with both matter and radiation. When a magnetar unleashes a pulse of X-rays, that radiation is directly influenced by its magnetic field. If you can imagine throwing a ball through a powerful force field, you can understand how its trajectory would be altered. In the same way, the energy emitted by a magnetar is deflected and changed, meaning every observation shows us not just the star itself, but the tangible effect of its magnetic field on the universe. The impact of a magnetar on its cosmic environment is truly immense, and its influence extends far beyond radiation. These stars have been observed creating stellar winds so powerful they can sweep away and distort the matter around them. Think of a giant fan that doesn't just blow air, but carries away everything in its path. This process can have a major effect on interstellar gas and dust, thereby shaping the formation of new stars and the evolution of entire galaxies. But what happens when a magnetar enters an active phase? During these periods, truly remarkable phenomena take place. The gamma-ray bursts associated with magnetars are typically the result of a sudden, violent release of magnetic energy. This process is so powerful that it can produce flashes of gamma rays that outshine an entire galaxy, serving as a stark reminder of the colossal energy these objects can unleash. Compared to other stars, magnetars have a relatively short lifespan. Their intense magnetic activity and frequent bursts lead to rapid transformations, raising the fascinating question of how long a magnetar can exist before its energy finally fades. Although their time in the cosmos is fleeting, their influence is long-lasting, because as a magnetar decays, it disperses the very materials needed to create new stars and planetary systems. This cosmic cycle of life and death reminds us of the profound interconnectedness of the universe. Several magnetars have already been identified within our own galaxy. Their distribution isn't random. You find these magnetic titans in regions where massive stars have previously exploded as supernovae. The search for these objects in the Milky Way helps us gain a much clearer understanding of the history of star formation and the broader story of our galaxy's evolution. The connection between magnetars and modern physics, particularly Einstein's theory of relativity, is another fascinating aspect of their study. The theory of relativity demonstrates that gravity and magnetism are intertwined in very unusual ways, and magnetars serve as perfect natural laboratories where we can observe these principles in action. As we learn more about these objects, we find ourselves unraveling the very mysteries of space and time. The study of magnetars is more than just a scientific task. It also prompts profound questions about our own existence and what these objects can tell us about the universe as a whole. As we continue to explore these cosmic phenomena, we find that magnetars are not just stars. They are windows into understanding the fundamental nature of the cosmos. It is crucial that this research continues, with future missions and telescopes designed specifically to provide answers that still elude us. Each new discovery is an invitation to keep exploring and questioning the magnificent universe that surrounds us. These cosmic marvels, known as magnetars, are far more than just neutron stars. They wield magnetic fields so immense they defy our current comprehension. This raises some profound questions. What impact do these fields have on the space that surrounds them? How exactly do they engage with their cosmic environment? The answers to these inquiries are as captivating as they are mind-boggling. First, you have to appreciate the sheer magnitude of a magnetar's magnetic field. Try to picture a standard refrigerator magnet. Then imagine amplifying its power millions of times. A magnetar's field can reach an intensity of 10 to the 15th power Gauss, which is approximately 1,000 trillion times stronger than the magnetic field of our own planet. To put it another way, if you were anywhere near a magnetar, you would witness metal objects being drawn to it with the ease of a paper scrap caught in a breeze. This incredible intensity doesn't just affect large objects. It fundamentally alters the behavior of matter at a subatomic level. For instance, electrons, which typically move freely through space, are compelled to change their direction and velocity. Inside a magnetar, These particles engage in what looks like a chaotic dance on a violently spinning and twisting floor. This process is called magnetohydrodynamic kinematics, a term describing how magnetic fields govern the motion of plasma, the very substance that constitutes most of the universe. The influence of these magnetic fields isn't confined to nearby matter. It can actually warp space-time itself. Imagine a magnet so potent that it doesn't just attract physical objects, but actually bends the fabric of reality around it. Magnetars are capable of this, generating streams of particles detectable across enormous distances. Even light, which you normally expect to travel in a straight line, has its path altered. In the presence of such a powerful magnetic field, a photon can be forced to change direction, a phenomenon known as birefringence, which essentially causes the magnetar to function as a cosmic prism, splitting and redirecting light that passes nearby. The magnetar's influence also extends to the radiation it emits. During its active phases, it sends out powerful pulses of X-rays and radio waves, which are a direct consequence of its magnetic field. This radiation is so concentrated that if you were close to the magnetar, the levels would be instantly fatal. From a distance of thousands of light years, however, these pulses transform into precious data for astronomers, helping them unravel the nature of these enigmatic objects. Furthermore, energetic bursts from the magnetar's surface, called flares, unleash a tremendous amount of energy that can ionize atoms in the surrounding space, acting like cosmic fireworks that leave a glowing trail of charged particles. These energy bursts and pulses also have a significant impact on the interstellar medium. They can propel gas and dust across space, generating shock waves that influence the formation of new stars. In this way, a magnetar, which might seem like a remote and solitary object, can actively contribute to the birth of new generations of stars and planetary systems. And while you might think of them as static, magnetars are in fact highly active and unpredictable celestial bodies, a quality that only deepens the scientific fascination with them. The interaction between a magnetar's magnetic field and its cosmic neighborhood can also induce structural changes in nearby matter. For example, the field is so strong it can warp space-time in a way that is comparable to the effect of a massive object like a black hole. This is a phenomenon scientists are actively studying, as it could hold clues to the fundamental workings of the universe. It's also theorized that, as matter is exposed to these fields, its atomic structure can be altered, potentially leading to the creation of entirely new types of particles and opening a new frontier in our quest to understand fundamental physics. It's truly astonishing to realize that these extreme magnetic fields are more than just scientific oddities. They hold the potential to give us profound insights into the origins of the cosmos. Every time we observe a magnetar, we are essentially peering through a window into the very processes that shape the stars and galaxies we see today. In this respect, magnetars serve as cosmic fossils, preserving the history of the universe within their incredibly intense magnetic fields. A magnetar's ability to influence its surroundings also brings up some fascinating questions about how it might interact with other celestial bodies, like stars and planets. What would be the effect on Earth if a magnetar were located relatively close to our solar system? The answers are not only crucial for astrophysics, but also compel us to contemplate our own place within the grand scale of the universe. As we continue our exploration of the cosmos, magnetars stand out as a particularly promising field of research. Every new discovery about their magnetic fields and their behavior inches us closer to understanding not just these specific stars, but the fundamental mechanisms that govern the entire universe. Ultimately, it is our innate human curiosity and the relentless drive to comprehend the unknown that propel us to keep exploring and learning. So the next time you think about a simple magnet, I want you to remember that there are magnets out in the universe that are immeasurably more powerful and intriguing than anything we can conceive of on Earth. With their extreme magnetic fields and their staggering effects on the cosmos, magnetars serve as a constant reminder that the universe is teeming with mysteries just waiting for us to uncover them. Within every X-ray pulse and each gamma-ray burst, there is a new story to be told and fresh knowledge to be gained. With every pulse or outburst from a magnetar, researchers are granted a new chance to comprehend these enigmatic celestial bodies. By consistently monitoring their activity, astronomers can construct a more detailed map of our galaxy's mechanics. On a more fundamental level, magnetars push the limits of our physical laws, compelling us to question our theories and re-examine everything we thought we knew about gravity, matter, and energy. Each insight we gain about them only sparks new questions, propelling our quest for deeper exploration. So, what further secrets might we uncover from these mysterious objects drifting through the core of our cosmos? Absolutely none of this investigation would be feasible without the advanced technology available to us today. Specialized telescopes and satellites, engineered to detect X-rays and radio waves, enable us to capture the powerful bursts of energy that magnetars release. Every single pulse acts like a transmission on a cosmic frequency that we are now able to tune into, offering us a direct view into the processes shaping the universe. The sheer complexity of magnetars forces a profound reevaluation of how you and I perceive the cosmos. It is entirely possible that by examining these objects, we are merely glimpsing the very edge of a far greater universal knowledge. The intricate relationship between magnetism and matter, bridging the gap between what is seen and what is unseen, inspires us to relentlessly pursue answers and continue our exploration. The magnetic fields of magnetars represent a phenomenon that truly boggles the mind, possessing an incredible capacity to warp both space and matter around them. They present a captivating lesson on the fundamental forces that sculpt our reality. As our observations continue, you should remember that every magnetar tells its own unique story, serving as a powerful testament to the intricate beauty of the universe we call home. Gamma-ray bursts stand as one of the most thrilling and perplexing occurrences in the cosmos, with magnetars frequently taking center stage in these cosmic dramas. To grasp what these bursts truly are and why they're so intimately connected to magnetars, it helps to first think about energy. Picture a soda bottle that you have shaken intensely. The moment you open it, all that pent-up pressure erupts in an explosion of foam. This very principle operates in space, but on a scale that is nearly impossible to conceive. Owing to their extraordinarily powerful magnetic fields, magnetars accumulate an astonishing quantity of energy. To give you some perspective, their magnetic fields are so potent that they can unleash more energy in a single moment than our sun will produce over its entire 10 billion-year lifespan. This release happens because of the peculiar behavior of matter within the magnetar itself, where immense stress can cause the star's crust to fracture, releasing a flood of energy as gamma rays. This process is not unlike a kernel of popcorn bursting when intense heat builds up unbearable internal pressure. Consequently, the gamma-ray bursts that we detect from Earth are effectively the distress signals broadcast by these colossal objects. When a magnetar unleashes a gamma-ray burst, the event is incredibly brief, yet violently explosive, lasting anywhere from a few milliseconds to several minutes. Their luminosity is so extreme that they can be seen from billions of light-years away. Imagine you are standing in a pitch-black forest when someone suddenly ignites a firework. The resulting flash is so brilliant that it momentarily illuminates your entire surroundings, well before the sound reaches you. This is a fitting analogy for how these cataclysmic explosions travel to us from the far reaches of space. The study of these bursts is critical because it gives us a direct window into how matter behaves under the most extreme conditions imaginable. When a magnetar erupts, the emitted gamma rays carry vital information about its internal structure and composition. This data is indispensable, not only for understanding magnetars themselves, but also for comprehending the fundamental physics that governs the entire universe. You can think of each burst as a coded message from the cosmos that scientists are diligently working to decipher. Beyond what they tell us about magnetars, these bursts also function as cosmic time machines, allowing us to witness events that transpired billions of years in the past. By analyzing these phenomena, you and I can piece together the universe's history, from the formation of early galaxies to the evolution of stars over cosmic timescales. It is as if we are receiving a direct message from a long-vanished, ancient civilization. But the story doesn't end there. The immense energy unleashed during these explosions has a profound impact on the magnetar's immediate cosmic neighborhood. Highly energetic gamma rays can ionize surrounding matter, which means they can strip electrons from atoms and alter the chemical makeup of nearby gas clouds. This process can directly influence the birth of new stars, thereby shaping the evolutionary path of entire galaxies and showcasing magnetars as both destroyers and creators. Astronomers have cataloged thousands of gamma-ray bursts, yet it is important to note that not all of them originate from magnetars. Many are the result of other cataclysmic events, such as massive supernova explosions, or the collision of two neutron stars. Each type of event produces its own distinct signature, which allows scientists to distinguish their origins and understand their underlying nature. Detecting these bursts, however, is an exceptionally challenging endeavor. Gamma-ray bursts are incredibly fleeting and can appear unpredictably anywhere in the sky. Despite this, thanks to significant technological progress and highly specialized observatories, scientists are now able to systematically record and analyze these events. Every new burst that is detected is like discovering a single needle in a vast cosmic haystack, offering a fresh opportunity for learning. The ongoing study of magnetars and their gamma-ray bursts has been a catalyst for entirely new theories in the field of astrophysics. The extraordinary behavior of these cosmic giants often conflicts with our established understanding of the laws of physics. For instance, data from these events has compelled physicists to re-examine certain tenets of both relativity and quantum mechanics, with each new discovery bringing us one step closer to a more complete picture of the universe. It is crucial to recognize that magnetars, separated from us by millions of light years, still underscore your connection to the wider cosmos. Every gamma-ray burst we detect serves as a powerful reminder that the universe is teeming with mysterious wonders. These events not only push the limits of our understanding, but also compel you to consider your own place within this immense and cryptic reality. So, when you next encounter information about a magnetar and its powerful gamma-ray emissions, remember that each burst contains the potential to deepen our knowledge of the universe and your role in it. Every one of these cosmic flashes is a spark against the blackness, lighting the way toward new questions and future discoveries. Magnetars are true cosmic wonders that provide you a glimpse into some of the most unusual events in the universe. But to comprehend the X-ray pulses they generate, you must first recognize that a magnetar is a unique class of neutron star. These objects function like cosmic beacons, emitting flashes of tremendously intense radiation that we can observe from afar. Imagine a flashlight that doesn't shine steadily, but instead blinks intermittently. This is similar to the X-ray pulses from magnetars. These are no ordinary flickers, however. As their power is so immense, they can be registered from billions of light years away. This means that when you observe these signals, you are essentially looking into the distant past, at events that transpired eons ago. So, what constitutes these X-ray pulses? They are fundamentally composed of high-energy photons produced at the magnetar's surface, a region where gravity is so powerful that it accelerates electrons to astonishing velocities. You can visualize this process like a car accelerating rapidly on a highway, only in this case, the highway is the star's exceptionally strong magnetic field. When these electrons approach the speed of light, they trigger a chain reaction that unleashes a staggering quantity of energy as X-rays. It's important to note that not all magnetars behave identically. Some exhibit greater activity than others, emitting their X-ray pulses with higher frequency. A variability that fascinates astrophysicists because it offers a window into the internal dynamics of these celestial bodies. Each pulse we register can reveal something new about the magnetar's internal composition, almost as if you are monitoring the heartbeat of a cosmic giant. The information embedded in these pulses is rich. Fluctuations in the frequency and intensity of the X-rays can expose details about the star's magnetic field and its rate of rotation. As a magnetar spins, its magnetic field interacts with the surrounding space, generating shock waves that manifest as the very pulses our telescopes detect. It is as if the magnetar is broadcasting signals across the cosmos, enabling you to decipher its history and makeup. At times, these X-ray pulses can escalate into full-blown explosions known as bursts. These bursts are fleeting yet extraordinarily potent events, capable of releasing more energy in a moment than our own sun will produce over its entire existence. They are a stark reminder of the violent and energetic nature of magnetars, and their study helps you better understand the mechanics of energy release throughout space. Some scientists liken the analysis of X-ray pulses to listening to a symphony in a room full of instruments, where each instrument contributes its unique tone and rhythm. By analyzing the pulses arriving from magnetars, researchers can discern the melody of their activity, identifying patterns and anomalies that offer clues to their underlying behavior. The relationship between a magnetar's rotation and its emissions is also captivating. The spin can accelerate the release of X-rays, resulting in rhythmic pulses that sometimes show unexpected variations. This leads you to wonder if these pulses are a form of cosmic communication or merely a byproduct of the extreme physics that governs their being. The answer remains elusive, but the study of these signals is a primary method for unlocking the secrets of these stars. Beyond their intrinsic interest, X-ray pulses also function as invaluable tools for cosmic exploration. By examining these rays, astrophysicists can investigate dark matter and dark energy, the mysterious components that constitute the vast majority of the universe. In this sense, magnetars serve as celestial lighthouses, illuminating the path toward a deeper understanding of the cosmos. One of the most compelling questions is how these pulses might influence their local environments. The answer is found in the interplay between their magnetic fields and the surrounding space, which can create effects that challenge your imagination. As X-rays travel outward, they can reshape the structure of gas and dust clouds, thereby impacting the formation of new stars. Although magnetars are incredibly remote, their influence is felt directly in our pursuit of knowledge. Every pulse you receive is an opportunity to learn more about the limits of the universe and the fundamental laws that define it. As we explore the connection between X-ray pulses and magnetars more deeply, you come to realize that each new finding brings us closer to comprehending not just these stars, but the very fabric of the cosmos itself. Within every burst lies a story waiting to be deciphered, and each of those stories connects you more profoundly to the universe. The X-ray pulses from magnetars are among the most captivating phenomena in modern astrophysics. By studying them, you not only solve the puzzles of these incredible objects, but also broaden your understanding of the universe and your own place within it. This exploration is more than a journey into the unknown. It's a reminder that in this vast and awesome cosmos we call home, there is always something new waiting to be discovered. Magnetars, however, elevate this entire concept to an extraordinary new level. You might ask what truly distinguishes them from other neutron stars, and the answer is found within their unbelievably powerful magnetic field. These objects are essentially the titans of the cosmos, possessing magnetic forces that dramatically overshadow those of their stellar relatives. A magnetar's magnetic field can be 1,000 times more potent than that of a conventional neutron star, a difference in scale that is difficult to comprehend. To help you grasp this, consider a common refrigerator magnet, whose magnetic force is just sufficient to hold a few pieces of paper. Now, try to envision a magnet with the power to suspend an entire skyscraper. That gives you an idea of the sheer magnitude of a magnetar's magnetic influence. But you may wonder why this incredible force is so important. Its significance becomes clear when we observe how it warps the very environment around it. While a regular neutron star certainly has a strong magnetic field, a magnetar's is so intense it can literally distort the fabric of space, almost as if it's rewriting the laws of gravity and giving rise to bizarre phenomena like gamma-ray bursts. When you place a magnetar alongside other types of neutron stars, the contrasts become quite striking. Although neutron stars are born from the collapse of giant stars, the majority possess magnetic fields that, while powerful, do not reach such extremes. Magnetars represent a unique class whose magnetic field is generated through a different process, granting them their singular properties and making them a sort of enhanced version of their cosmic cousins. Furthermore, a magnetar's existence is far more brief and violent, whereas a typical neutron star can persist for millions of years. This fleeting life cycle is a direct result of a magnetar's intense magnetic field, which fosters instability and triggers massive bursts of energy detectable from thousands of light years away. It's as though you have a star that doesn't just radiate light, but also ignites spectacular cosmic fireworks. These observations naturally lead to a compelling question. How can we possibly study such distant and extreme events? Astronomers rely on telescopes specifically designed to detect X-rays and gamma rays, which function as our windows into a universe invisible to the naked eye, allowing us to learn a great deal about the nature and behavior of magnetars. Among their most fascinating characteristics are the gamma-ray bursts they produce. These explosions act like brilliant cosmic beacons that cut through the darkness of space, revealing crucial details about the lives of these celestial bodies. Each time a magnetar erupts, it unleashes a wave of energy that our instruments on Earth can capture, enabling us to analyze its composition and probe its internal structure. As our investigation into magnetars deepens, we are also discovering their connections to other astrophysical events. For instance, research has revealed that magnetars can actively influence the creation of new stars in their galactic neighborhood. Their formidable magnetic fields can compress vast clouds of gas and dust, establishing the perfect conditions for stellar nurseries to ignite. In this way, they function almost like cosmic architects, actively sculpting the raw material of the universe around them. At this stage, you might be curious about the broader role magnetars play in the evolution of the cosmos, and the answer is that they are pivotal actors in the life story of galaxies. Their immense energy not only impacts nearby celestial objects, but can also shape how entire galaxies develop over vast stretches of time. This makes magnetars much more than simple astronomical oddities. They are, in fact, fundamental to our complete understanding of the universe. As new theories emerge and further research is undertaken, profound questions about the future of these enigmatic objects continue to surface. Could magnetars offer us new insights into the fundamental nature of gravity and space-time? What other incredible secrets might they be concealing? Each discovery we make seems to unlock a new set of puzzles, which is precisely what makes the scientific endeavor so thrilling. Comparing magnetars to other neutron stars doesn't just underscore their magnetic distinctions. It also reveals the sheer diversity and wonder of the natural world. Every piece of knowledge we gain about these cosmic behemoths brings us a step closer to deciphering the mechanisms of the universe and recognizing the intricate web that connects everything within it. Ultimately, when you contemplate magnetars, it's impossible not to be in awe of the forces that govern the cosmos. These phenomena are not only intellectually captivating, but also serve as a profound reminder of our own smallness in the face of the universe's immensity. The quest for answers about magnetars is, in a way, a search for ourselves, for our own place in this vast expanse and for a deeper understanding of the forces that shape our existence. So, the next time you gaze up at the night sky, remember that somewhere out there, these magnetic giants exist, constantly challenging our knowledge and beckoning us to continue exploring the mysteries of space. The life of a magnetar is an astonishing journey filled with incredible events. For many, it might be challenging to imagine how a star's existence can be both so transient and yet so immensely powerful. So, what exactly is the life cycle of a magnetar, and what are the stages it progresses through during its time in the cosmos? The story begins with a colossal star, a giant that has spent its life engaged in nuclear fusion deep within its core. For millions of years, this star burns with incredible luminosity, forging heavier elements as it consumes its vast reserves of hydrogen. However, as its life draws to a close, a decisive moment arrives when its fuel is depleted, and the star must meet its ultimate fate. In a final spectacular display, the star explodes in a supernova, a cataclysmic event so bright it can briefly outshine its entire home galaxy. But instead of fading into nothingness, an extraordinary remnant is left behind, a magnetar. Following the supernova, the star's core implodes under the crushing force of its own gravity, creating conditions of extreme pressure and temperature. In this crucible, the density becomes so great that electrons and protons are forced to merge, forming neutrons and giving birth to a neutron star. Yet, not all neutron stars are created equal. A select few, the magnetars, are endowed with an unbelievably potent magnetic field, one that is millions of times stronger than any magnet you might find on Earth. This unique characteristic is what sets them apart and defines their dramatic, albeit short, existence in the universe. This powerful magnetic field is a product of the star's swift rotation, combined with intricate dynamics deep within its core. You might wonder, how long can a magnetar sustain this phase of its existence? The reality is surprisingly brief, just a few thousand years. Despite their immense power, these cosmic objects are far from eternal. Their lifespan is a brilliant, fleeting spectacle in the vastness of space that quickly extinguishes itself. Over time, as the magnetic field gradually weakens, the magnetar evolves into what we recognize as a standard neutron star. Yet, in its short and brilliant lifetime, it can exert a profound influence on its cosmic neighborhood. During its active period, a magnetar is capable of producing enormous gamma-ray bursts and X-ray pulses, creating events that resemble spectacular cosmic fireworks which reshape their environment. The sheer energy unleashed during these outbursts is so powerful that it can disrupt nearby matter and, under certain conditions, even act as a catalyst for the birth of new stars. If you can picture a single spark setting off a massive fire, you have a good sense of the scale of a magnetar's impact on its surroundings. This is precisely why these explosive events are so significant for us to study. Even with their brief lifespans, magnetars represent incredible subjects of study for astrophysicists, offering invaluable data on physics operating under the most extreme conditions imaginable. Studying how a magnetar interacts with its environment, the way it affects other stars, and how its energy bursts travel across space, provides us with crucial clues to unlocking the deeper mysteries of the cosmos. It is remarkable to consider that while magnetars themselves are short-lived, their legacy is incredibly long-lasting. The gamma-ray bursts they unleash can be observed from billions of light-years away, potentially giving us data on the very expansion of the universe itself. In this way, you can think of magnetars as cosmic envoys, carrying vital information across the vast distances of space and time. As a magnetar continues to age, its magnetic field diminishes, and it gradually radiates away its energy. It ultimately settles into the state of an ordinary neutron star, which may still have a powerful magnetic field, just not one of the same incredible intensity. You could compare this to a world-class athlete who retires after years of competing at their peak. While they no longer perform at that level, their impact and contributions remain significant. A magnetar might also alter its location within the galaxy throughout its existence. Its interactions with the surrounding cosmic environment mean it can be affected by the gravitational pull of other stars and even black holes. This journey can lead it to unexpected regions, transforming it into a galactic wanderer that carries the full history of its dramatic formation and subsequent evolution. The end of a magnetar's life is just as intriguing as its active phase. At some point, it will cease to emit energy and will cool down, transitioning into a much more placid, inert object. Although its vibrant activity will have faded, its fundamental presence will stay imprinted on the fabric of the universe, serving as a reminder of the transient nature of stellar brilliance. The entire life cycle of a magnetar teaches us that even the most formidable objects in the cosmos have a finite existence. They are born from the fury of supernova explosions, burn with incredible intensity for a cosmically short period, and then ultimately fade from view. However, their influence on the universe continues long after their light has gone out, leaving behind a legacy that reverberates through the ages. Ultimately, a magnetar's existence is an extraordinary odyssey defined by immense energy and profound transformation. It provides us with deep insights into the workings of the universe and reminds us that, within the grand cosmic expanse, every single star has a unique story that deserves to be told. Within the vastness of our own galaxy, magnetars are akin to brilliant yet exceptionally scarce jewels. Current estimates place the number of known magnetars in the Milky Way at roughly 20, although a great many more may still await discovery. Can you even conceive of a star whose magnetic field is so potent that it seems to defy the known principles of physics? This is the very quality that makes magnetars so utterly captivating. Most of the magnetars that have been identified are the remnants of supernova explosions, which mark the spectacular final moments in the lives of massive stars. These cosmic wonders are typically found in active star-forming areas like young clusters. Much like precious gems in a display, they are often concealed amidst the countless other stars that surround us. Among the most renowned of these objects is SGR 1806-20, situated approximately 20,000 light-years away from us. This particular magnetar has been the source of astounding events, including gamma-ray bursts that have left astronomers completely spellbound. The immense distance separating us from these objects offers a special vantage point, allowing their energy to reach us as light and radiation, so we can probe their secrets from afar. The placement of magnetars also carries significant implications for how galaxies themselves evolve over time. As exceptionally dense and powerful objects, their activity can physically change the matter around them. Just as a stone tossed into a pond creates ripples that spread across the entire surface, a magnetar's magnetic fields and explosive bursts can directly influence the formation of new stars. There is another, especially compelling magnetar, designated 1E1048.1-5937, which resides right in the turbulent heart of the Milky Way. Its presence serves as a powerful reminder that these objects can thrive even in the chaotic, high-gravity environment of the galactic core, forging their own cosmic narratives. This discovery naturally leads you to wonder what other secrets our galaxy might be hiding. The sheer variety observed among magnetars is also remarkable, with some being older and more subdued, while others are young and intensely luminous. This diversity provides us with a glimpse into the various life stages of these incredible objects. It's as if each magnetar represents a different chapter in a grand cosmic book, telling a unique story about the birth and fate of massive stars. This then raises the question of how scientists have managed to find these elusive objects in the first place. With today's advanced technology, astronomers can now pick up the radiation and gamma-ray bursts that magnetars release. Each pulse of X-rays or gamma rays they send out acts like a cosmic cry for help from the void, inviting us to investigate and comprehend the events unfolding there. These objects are fascinating not just for their inherent properties, but for what they signify within the grand scheme of the universe, reminding us that undiscovered forces and phenomena are still waiting to challenge our current grasp of physics. The way magnetars are scattered throughout the galaxy prompts questions about their origins and why they seem to group together. Some hypotheses propose a connection to areas of intense star formation, where enormous stars are born and ultimately perish in breathtaking supernovas. This suggests that by examining magnetars, you can uncover valuable clues about our galaxy's past and the complete life cycle of stars. Our search for magnetars has spurred the development of specialized telescopes and space missions designed to peer into cosmic darkness and capture their fleeting light and radiation. You can think of these sophisticated instruments as high-tech treasure hunters, equipped to detect the powerful bursts of energy these enigmatic objects emit. Every new find advances our understanding of their fundamental nature and their overall impact on the cosmos. The significance of magnetars extends far beyond their captivating existence, as they offer profound lessons about life in the universe and the extreme states to which matter can be subjected. By figuring out how they operate, you can start to untangle the deep puzzles of modern physics and see how these cosmic principles connect back to our own world, prompting us to ask what we might learn from these cosmic powerhouses. In the end, the quest to find and study magnetars in the Milky Way is more than just a voyage across space. It's an expedition to the very frontiers of human knowledge. Every magnetar we locate presents a fresh chance to learn about the universe's fabric and our own position within it. In this immense and enigmatic cosmos, these objects serve as a constant reminder that discovery is endless, and that each solution often unlocks a host of new questions. When you consider magnetars, their strange properties are naturally captivating. but you might wonder how they relate to Einstein's theory of relativity. To grasp this, you first have to remember that relativity reveals space and time aren't distinct entities, but are woven together into a single fabric known as the space-time continuum. This integrated framework serves as the very stage upon which all cosmic events unfold, and an object's mass can warp it, much like a person sitting on a trampoline causes the surface to sag. A magnetar is a type of neutron star defined by an incredibly powerful magnetic field, and its immense density creates a significant distortion in the surrounding space-time. This magnetic field is so potent that it can actually alter the path of light, a core idea within the theory of relativity. According to this theory, gravity isn't a force, but rather a manifestation of this curvature in the space-time continuum. And a magnetar's concentrated mass and field create a profound dent in this cosmic fabric, influencing not just its immediate vicinity, but objects at much greater distances as well. This brings us to the topic of gravitational waves. When two colossal objects, such as a pair of magnetars, orbit one another, they generate disturbances in the space-time continuum that spread outward like waves. You can visualize this as the ripples that expand across a pond after a stone is tossed in. The ability to detect these gravitational waves has fundamentally changed how we perceive the universe, providing an entirely new method for observing extreme cosmic phenomena, including those involving magnetars. Gravitational waves carry the narratives of cataclysmic events happening throughout space. For instance, when a magnetar collides with another massive body, the energy release is staggering, producing gravitational waves that our highly sensitive instruments can measure. This allows you not only to witness these events, but also to better comprehend the behavior of magnetars and their role in the universe, pushing the boundaries of modern physics, where the extreme conditions near these objects may even challenge our existing theories of gravity. The link between magnetars and relativity also invites you to consider how these incredible magnetic fields influence light passing nearby. Light traveling in close proximity to a magnetar can be bent, which produces bizarre and fascinating visual phenomena that astronomers can analyze. This interplay between light and a magnetar's gravitational field remains a vibrant field of research, showing that relativity is a powerful tool for unraveling cosmic mysteries. Ultimately, magnetars serve as natural laboratories where you can see relativity in action, and every new piece of information we gather brings us closer to a complete understanding of how the universe truly works. The relationship between magnetars and relativity compels us to consider the trajectory of scientific inquiry. As our comprehension of physics deepens, these celestial objects will continue to be crucial for tackling fundamental questions about the fabric of space, time, and gravity. Pursuing the solutions to these puzzles is a thrilling expedition that consistently unveils the elegance and intricacy of our cosmos. This exploration underscores that every new insight into magnetars represents not just an advance in astrophysics, but a clearer view of ourselves and our position in the universe. Magnetars are captivating not merely for their immense magnetism, but also for their direct association with phenomena that push the limits of our cosmic understanding. One of the most compelling of these links is their relationship to gravitational waves. But what exactly are these waves, and why is their connection to magnetars so significant? Think of gravitational waves as ripples in space-time itself, produced not by a pebble in a pond, but by the most violent events the universe has to offer, like colliding black holes or exploding stars. When such a cataclysmic event unfolds, it warps the very structure of the cosmos, sending these waves propagating outward. This is precisely where magnetars enter the picture. Their staggering gravity and powerful magnetic fields can directly influence the generation of gravitational waves, which makes studying them essential for understanding both these exotic stars and the fundamental nature of the universe. In essence, any energetic outburst from a magnetar can create gravitational waves, allowing us to effectively listen to events happening thousands of light years away. So, how do we actually detect these cosmic reverberations? We rely on incredibly sensitive instruments, such as the Laser Interferometer Gravitational Wave Observatory, or LIGO, which famously made the first ever direct observation of gravitational waves back in 2015. This technology is capable of sensing the minuscule vibrations these waves cause as they pass through our planet. However, the true challenge lies in the fact that these waves, while fascinating, are extraordinarily faint and difficult to capture, making this a field of research defined by both immense difficulty and profound excitement. Magnetars, with their rapid rotation and unparalleled magnetic fields, are prime sources for powerful energy releases that can, under specific circumstances, generate these gravitational waves. These releases, known as gamma-ray flares, are catastrophic occurrences that can unleash more energy in moments than our sun will produce in its entire lifespan. When a magnetar undergoes such a flare, it can dispatch gravitational waves across space, providing us with a unique way to gather data about its composition and activity. By analyzing how and when these waves are created, we can uncover vital clues about the internal structure of magnetars and the extreme physics at play within them. Gravitational waves serve as a kind of cosmic probe, letting us perceive secrets that would otherwise be completely invisible to our most powerful telescopes. Furthermore, observing these waves helps us build a more complete picture of other extreme cosmic events, like the formation of black holes and the mechanics of supernova explosions, ultimately bringing us closer to solving the great mysteries of our universe. Each time we register a gravitational wave, it's like receiving a transmission from the distant past, a message detailing an event that took place millions of years ago. As our technology and analytical methods improve, we are becoming more adept at decoding these cosmic signals. While magnetars are certainly not the only sources of gravitational waves, their distinctive magnetic properties and dynamic behavior make them exceptionally valuable subjects for this area of study. Consider a future where detecting gravitational waves is a routine part of astronomy. In that reality, magnetars could function as cosmic lighthouses, helping us navigate the vastness of space. These beacons would not only deepen our understanding of the universe, but could also yield revolutionary insights into the true nature of gravity and space-time. Studying these phenomena offers a profound perspective on our own existence, connecting us to the cosmos on a much deeper and more significant level. So as you contemplate the connection between magnetars and relativity, recognize that you are considering a phenomenon with the power to fundamentally alter our view of physics and the cosmos. These extreme objects serve as a constant reminder that there is still so much left to explore and comprehend in the vast expanse around us. With every new observation and theory, we inch closer to a future filled with astonishing and transformative discoveries. Each gravitational wave we detect carries with it an echo of the universe's ongoing narrative, a story that is continuously materializing right before us. You see, magnetars are far more than just simple stars. They function as genuine cosmic factories capable of shaping the birth of new stars and directing the course of galactic evolution. How, then, can these magnetic behemoths exert such a monumental influence on their cosmic neighborhoods? The explanation is rooted in their immense energy and extraordinarily powerful magnetic fields, A magnetar typically comes into being from the explosion of a colossal star, an event that not only unleashes a staggering amount of energy, but also profoundly reshapes the local environment. You can think of it as a pyrotechnic display on a truly universal scale, where the force is so great it can initiate the formation of new stars. The released energy can be so powerful that it compresses nearby clouds of gas and dust, establishing the ideal conditions for stellar nurseries to ignite. In this way, magnetars serve as powerful catalysts within the vast workshop of the cosmos. Their impact, however, extends even further, as their influence is not limited to just this initial explosive burst. A magnetar's magnetic field, which is billions of times more powerful than our planet's, governs the behavior of all matter in its vicinity. This incredible magnetism can draw in and structure cosmic gas clouds, facilitating the creation of new stars. Consequently, a magnetar's life story doesn't conclude with its own existence, but instead can launch the beginning for an entirely new stellar generation. To visualize this, picture a colossal magnet on a surface covered with iron filings, which it arranges into structured patterns. In a similar fashion, a magnetar's magnetic field orchestrates the surrounding gas and dust, forging dense pockets where starbirth can occur. This mechanism could be a fundamental driver of galactic evolution, suggesting that without these cosmic magnets, the state of space might look completely different. The link between magnetars and star formation also plays out across vast timescales. As a magnetar's energy diminishes, it can leave behind a wake of matter and energy that eventually coalesces into new stars. You can compare this legacy to how decaying organic matter fertilizes the soil for new life to flourish, illustrating a cosmic cycle of destruction and creation, where an end signals a new beginning. Furthermore, the influence of magnetars is not confined to just gas and dust. They can also affect stars that are already in their formative stages. The fierce radiation and gamma-ray bursts they unleash can transform the stellar environment, generating conditions that are either perfect or hostile for the growth of other stars. It is almost as if the magnetar wields the authority to determine which stars are permitted to shine. As scientists delve deeper into these cosmic events, they have come to understand that the presence of magnetars can serve as a diagnostic tool for a galaxy's overall health. The quantity and arrangement of these magnetic titans offer vital clues about a galaxy's evolutionary past. For instance, the fact that some galaxies host more magnetars than others could point to distinct histories of formation, enriching our comprehension of the universe at large. Some astronomers propose that magnetars might even be the missing piece in our understanding of how larger structures, like galaxy clusters, are formed. These incredibly powerful objects possess the capacity to shape the gravity and dynamics of the galaxies around them. This elevates magnetars to a position of being essential components in the grand puzzle of cosmology. Even though magnetars appear to be incredibly distant and enigmatic phenomena, their study offers you a privileged view into our own position within the cosmos. By observing them, we gain insights into the very processes that forged the galaxy we call home. The evolution of our universe is deeply connected to the life and death of these cosmic magnets, and every new piece of data brings us a step closer to solving its deepest riddles. The tale of magnetars is not merely the biography of a star, but a narrative of profound influence and widespread creation. Across the immense expanse of the universe, every magnetar fulfills its function in a grand cosmic drama, reminding us that even the most extreme events are part of a much larger life cycle. With every scientific advancement, we are likely to uncover more about how these objects guide star formation and galactic change. It is possible that in the near future we will be able to directly observe these cosmic powerhouses in action and witness their transformative capabilities firsthand. So, the next time you gaze upon the night sky, remember that hidden among those glittering points of light could be the lingering echoes of magnetars that were pivotal to the universe's history. Our fascination with these objects stems not just from their extreme nature, but from how they connect you to the past and future of the cosmos. The captivating nature of magnetars has seized the imagination of many, not only due to their extraordinary properties, but also because of their portrayal in popular culture. What precise role do they play in shaping our perception of the universe? And why have they so often been cast as central figures in science fiction stories and movies? The allure of these extreme celestial bodies extends beyond their raw magnetic force, touching upon how they compel us to reflect on the universe and our place within it. In science fiction films and television series, you will often find magnetars depicted as fountains of limitless energy, or as the catalysts for galaxy-spanning disasters. For instance, a common plot device involves the explosion of a magnetar, triggering a cascade of catastrophes that threaten Earth. This narrative isn't pure fantasy. It's grounded in the reality that gamma-ray bursts from a magnetar could, in theory, have catastrophic effects on our world. However, these fictional accounts typically amplify the immediacy of the threat, transforming magnetars into cosmic adversaries rather than treating them as the neutral astronomical phenomena they are. This dramatic exaggeration serves the story, but often misrepresents the actual, though remote, risk they pose to us. Their portrayal as villains is a creative choice that prioritizes suspense over scientific accuracy. Beyond tales of destruction, some literary works have toyed with the concept of magnetars serving as gateways to other dimensions or alternate realities. In these narratives, the object's incredibly intense magnetic field does more than just manipulate the surrounding space. It is shown to actively warp the very fabric of reality. This idea uses the magnetar's extreme physics as a plausible springboard for exploring fantastic possibilities and mind-bending cosmic journeys. Although this concept is entirely fictional, it encourages you to consider the possibilities presented by modern physics and how scientists might eventually discover new universal dimensions by studying these objects. Video games also draw on magnetars for inspiration, casting them as energy sources that you must either harness or evade. In many of these games, the magnetar serves as a strategic goal, requiring you to navigate its effects, which are often rendered with spectacular and dramatic visuals, sparking an interest in astrophysics in people who might otherwise have never considered it. However, not all of this is confined to the realm of fiction. The reality of magnetars has heavily influenced documentary films and educational programming, where they are showcased as genuine wonders of the cosmos. These productions aim not only to inform, but also to inspire future generations of scientists. By revealing the beauty and mystery surrounding magnetars, they nurture a sense of curiosity that can drive young people toward careers in science and technology. Magnetars have also made their mark in the world of music, where certain compositions have been inspired by these cosmic powerhouses, employing sounds that conjure the emptiness of space and the intensity of magnetic fields. This marriage of art and science shows how our innate curiosity about the universe can take many forms, from literature to musical scores. The cultural depiction of magnetars also brings up deeper philosophical questions about what it means to be such an extreme celestial object in a vast and enigmatic universe, prompting you to contemplate nature, existence, and your own understanding of time and space. Within popular culture, magnetars often serve as a symbol for forces that lie beyond our influence, which can resonate deeply with the challenges in our own lives. It's fascinating to see how magnetars, despite their incredibly technical and complex nature, have transformed into an accessible icon of modern science. This trend demonstrates how scientific concepts can be made more approachable and presented in a manner that connects with a wide audience, effectively making magnetars a bridge between scientific knowledge and public curiosity. The portrayal of magnetars has also shifted over the years. In earlier representations, they were often treated as just another variety of neutron star. As our scientific understanding grew more sophisticated, so did their depiction in media, reflecting a more profound appreciation of their unique properties and illustrating the deep connection between science and culture. Ultimately, the story of magnetars in popular culture serves as a powerful reminder that scientific discovery isn't reserved solely for experts. It invites each of us to join the conversation about the universe. These objects offer you a compelling place to start asking questions, exploring, and simply marveling at the sheer scale and intricacy of the cosmos. As our exploration of these extreme cosmic magnets continues, it is vital to recognize that every new piece of data can inspire fresh narratives. Magnetars are much more than mere subjects of study. They represent our unending quest for knowledge and comprehension. Through this interplay of science and culture, they will undoubtedly remain a source of wonder and inspiration for generations to come. Scientists have dedicated tremendous effort to solving the fascinating puzzles that magnetars present within our vast universe. The question of what future research into these extreme cosmic magnets will yield involves not just probing their fundamental nature, but also developing the tools and technologies to see them with unprecedented clarity. A crucial element in this pursuit is the advancement of telescopes, as our ability to study complex phenomena improves with our technology. Imagine an instrument capable of capturing not just visible light, but also the radio waves and gamma rays vital to understanding magnetar activity. International cooperation has become a cornerstone in this quest for answers, with institutions worldwide combining their efforts to create networks of observatories. This collaborative strategy enables the synthesis of data from across the electromagnetic spectrum, assembling a far more complete picture of magnetars and their behavior. What incredible breakthroughs might arise from this global scientific partnership? Space missions are also set to play a pivotal role, with probes venturing into deep space carrying instruments designed specifically to analyze the radiation from these objects, potentially revolutionizing astrophysics. Simultaneously, progress in artificial intelligence is completely changing how we process the data gathered from magnetars. Advanced algorithms can sift through immense volumes of information in moments, detecting subtle patterns that might otherwise elude human researchers. The study of how a magnetar's magnetic field influences its surroundings is also a high priority. Gaining insight into how these fields affect nearby matter and contribute to the birth of new celestial bodies could reshape our entire understanding of astrophysics. Finally, the significance of magnetars in the study of gravitational waves cannot be overlooked. With the development of new and more sensitive detectors, the prospect of observing events directly linked to magnetars is becoming increasingly tangible. Each new discovery paves the way for a host of new questions, and you can be sure that these cosmic enigmas hold secrets that will continue to challenge and inspire us for a very long time. A new chapter in cosmic history may open if we succeed in capturing the gravitational waves from colliding magnetars. As our investigation into these objects deepens, we are confronted with their profound connection to both quantum physics and the theory of relativity. It raises the question of whether these extreme celestial bodies could reveal the boundaries of our current scientific understanding. The convergence of relativity and quantum mechanics is a rich field for novel theories, and magnetars might just hold the key to resolving mysteries that have long puzzled us. Future inquiries will also concentrate on the sheer variety within the magnetar population, as they are not all uniform. Some exhibit far more activity than others, and their fundamental properties can differ dramatically. Exploring these variations promises to yield new insights into how these cosmic behemoths form and evolve over time. By cataloging the diversity of magnetars, we can construct a more comprehensive picture of these phenomena and trace their origins. The profound fascination with magnetars extends to considering their potential influence on our own planet. Despite being thousands of light years away, their powerful gamma-ray bursts have the capacity to affect Earth. This leads scientists to ponder whether a magnetar situated within our galaxy could ever pose a genuine threat to life. Simultaneously, popular culture has embraced these cosmic wonders, featuring them in films, literature, and science fiction, which in turn fuels public curiosity about astrophysics and may even inspire the next wave of astronomers. Ultimately, the future of magnetar research is a landscape filled with both immense challenges and incredible promise. Through global scientific collaboration, cutting-edge technological progress, and new methods of data analysis, we are getting ever closer to deciphering the secrets of these cosmic magnets. The discoveries that await us in the coming years will undoubtedly mark an exhilarating era in astrophysics, where each answer we find only opens the door to more profound questions and possibilities. However, investigating magnetars is an endeavor fraught with difficulty, as these enigmatic objects exist at the very edge of our current knowledge. Their extreme nature is a primary reason for this challenge. You have to imagine a location where gravity is so powerful it bends the fabric of space and time itself, and then add a magnetic field billions of times stronger than anything on Earth. Consequently, any instrument designed to observe their activity must be extraordinarily sophisticated. The vast distances involved present another significant hurdle. Most of the magnetars we know of are located thousands of light years from us, making their signals incredibly faint. To put it in perspective, trying to detect them is comparable to attempting to hear a whisper from across a massive concert hall. Even though their gamma-ray bursts are immensely powerful at the source, the light that finally reaches our instruments can be feeble and easily lost within the sea of cosmic background radiation. Adding to the complexity is the fleeting duration of their outbursts, which can appear and vanish in the blink of an eye. This ephemerality forces astronomers to maintain constant vigilance, ready to capture any transient signal that flashes across the sky. This task is akin to trying to photograph a bolt of lightning, requiring immense patience and perpetual readiness. Our technology, despite recent advancements in telescopes and X-ray detectors, still has inherent limitations and may lack the sensitivity needed to capture the subtle behavioral shifts of a magnetar. Furthermore, each magnetar possesses its own unique and unpredictable behavior, which makes studying them as a group even more demanding. It's like being a detective on a case where every piece of evidence only deepens the mystery. Their immediate surroundings are also far from ideal for observation, as the intense radiation they emit can interfere with our measurements. This is like trying to capture a clear image in the middle of a blinding storm. You need specialized equipment and a considerable amount of luck. To overcome these obstacles, international collaboration has become essential, with research teams from around the world pooling their data and coordinating observations. You can just imagine the immense effort required from numerous countries and scientists to focus on a single magnetar, forming a global team where every small finding contributes to the larger puzzle. Of course, this large-scale astrophysical research is incredibly expensive, which introduces the constant challenge of securing limited funding and prioritizing which cosmic mysteries warrant the most immediate attention. The future of research in this area often depends on the critical decisions reached in the meetings of funding organizations. We must also recognize the indispensable role of theory when it comes to magnetars, as many of our concepts about their mechanics are derived from physical models that are still in evolution. This requires scientists to remain ready to modify or even completely overhaul their theories when confronted with new evidence. What was once considered a scientific law can suddenly become a mere exception, forcing us to reevaluate our entire understanding of how these stars operate. Furthermore, the study of magnetars has a ripple effect across other scientific fields, with findings in astrophysics potentially reshaping areas like quantum physics or the theory of relativity. This web of connections is a powerful reminder that knowledge is not neatly compartmentalized, raising the question of what magnetars might teach us about physics as a whole. In the face of all these challenges, it is human curiosity that relentlessly propels the research forward, making every small advancement in our knowledge of magnetars a significant triumph. It's possible that the next major breakthrough is just on the horizon, waiting for the right scientist to uncover it at the perfect moment. The quest to understand these captivating cosmic entities is ongoing, and with every question we pose, we move a little closer to deciphering the universe's greatest secrets. But what if I were to tell you that magnetars, these mysterious and incredibly powerful cosmic objects, could offer us profound insights into quantum physics? In a cosmos where the fundamental laws are constantly under scrutiny, magnetars present a unique enigma that might help us comprehend the behavior of matter at the subatomic level. So, what makes these stars so extraordinary? And what is their link to the captivating realm of quantum physics? To grasp this connection, you must first remember that quantum physics governs the tiniest constituents of our universe, like electrons and protons. It asks you to envision a reality where the rules are fundamentally different from our everyday experience. In this subatomic world, particles can behave as waves, exist in multiple locations simultaneously, and even communicate instantly across vast distances, a bizarre reality that quantum physicists are dedicated to understanding. Magnetars, for their part, are a distinct class of neutron star possessing magnetic fields of such extreme intensity that they surpass any other known object in the universe. A magnetar's magnetic field can be 1 billion times more powerful than the magnet on your refrigerator. Just try to conceive of a force so immense it could attract objects from 1,000 kilometers away, because that is the scale we are discussing. So, how does this all tie back to quantum physics? The extraordinarily powerful magnetic fields of magnetars can directly influence the behavior of surrounding subatomic particles. This effectively transforms them into natural laboratories, where we can observe quantum phenomena that would be impossible to replicate otherwise. The combination of intense gravity and magnetism on a magnetar can compel particles to act in ways that completely defy our intuitive understanding of their interactions. This line of research has also compelled scientists to re-examine certain core tenets of quantum physics, sparking questions about what new facets of matter and energy magnetars might unveil. The prospect that these stars could hold clues to the nature of quantum gravity, the theoretical framework seeking to unite Einstein's general theory of relativity with quantum mechanics, is truly thrilling. Unlocking this connection might just be the key to understanding the deepest secrets of the cosmos. Magnetars are also renowned for their gamma-ray bursts, which are some of the most energetic events in the universe. Gamma radiation represents the highest energy form of light on the electromagnetic spectrum, and analyzing its generation within magnetars can illuminate how matter behaves under the most extreme conditions. By observing these outbursts, scientists can deduce information about a magnetar's internal structure and the way its magnetic forces manipulate subatomic particles. The release of energy as X-ray pulses from magnetars provides another special window into the world of quantum physics. These pulses act like cosmic strobes, giving us a momentary glimpse of matter's behavior in these intense environments. Through careful analysis of these pulses' characteristics, scientists can infer the properties of the matter and energy that constitute a magnetar, which is an incredible feat when you consider we are observing it from millions of light-years away. And the influence of these objects doesn't stop there. The very interaction between magnetars and their surroundings has quantum mechanical implications. For instance, the intense radiation they constantly emit can modify the behavior of particles in the adjacent space, cultivating an environment where the rules of quantum mechanics play out in new and different ways. This could forge new pathways for exploring how the fundamental forces of nature truly relate to one another. Think of magnetars as a colossal cosmic jigsaw puzzle, where each piece corresponds to a different aspect of physics. By studying these stars, we are methodically fitting those pieces together to achieve a more coherent picture of the universe. With research on magnetars actively underway, every new discovery holds the potential to reshape our entire understanding of quantum physics and could be the key to unlocking phenomena we have not even discovered yet, opening new doors in our grand quest for cosmic answers. In the vast expanse of the cosmos, magnetars stand out as enigmatic beacons, illuminating the deepest secrets of the universe. The lessons these potent celestial objects can teach you about your own place in the cosmos are as compelling as the magnetars themselves. Their extreme nature forces us to reconsider the fundamentals. As the universe's most powerful magnets, they generate fields trillions of times more intense than anything on Earth, a force with profound consequences for fundamental physics. This incredible power compels you to question how matter behaves under such extreme pressures and how these interactions might shape the behavior of matter across the cosmos. To truly comprehend the relationship between gravity and electromagnetism, you need look no further than these cosmic titans. The study of magnetars presents a captivating puzzle, leading scientists to develop a range of theories about their nature. A primary question driving this research is the origin of their phenomenal magnetic strength. One compelling hypothesis suggests their power is born from the extraordinarily violent collapse of a star. In this scenario, the star's rapid rotation and its magnetic field merge in a cataclysmic burst of energy, giving rise to a magnetar. This specific combination of factors could hold the answer to why these cosmic bodies are so exceptionally unique. An alternative theory proposes that magnetars might be neutron stars that experienced a dramatic amplification of their magnetic fields following a supernova. Imagine a spinning top accelerating to incredible speeds. Its energy builds with its rotation, and a similar principle might apply to these cosmic objects. This raises fascinating questions about the implications such a process could have for your understanding of space and time. Furthermore, you have to ask, could magnetars serve as a bridge to unifying the fundamental forces of physics? The notion that such an extreme and singular object might hold the key to connecting gravity and electromagnetism is truly captivating. Some physicists theorize that investigating these celestial bodies could pave the way for new breakthroughs in quantum physics, guiding you toward a revolutionary new model of the universe. One of the most intriguing possibilities is that magnetars are formed through a process that you do not yet comprehend. Could there be other dimensions or undiscovered phenomena that influence the creation of these objects? The idea that there is more at play than is currently visible encourages an exploration beyond the limits of your present knowledge. The hypothesis that a magnetar could function as a kind of progenitor star seeding the formation of other celestial bodies, is equally compelling. If a magnetar can shape its environment with its immense magnetic field, could it play an essential role in the birth of new stars? This concept makes you wonder how magnetars might guide the evolution of galaxies, potentially acting as architects of the cosmos. You also cannot overlook the profound effect magnetars have on the matter that surrounds them. Some scientists speculate that their powerful magnetic fields could fundamentally alter the structure of atoms in their vicinity. Do these cosmic forces give rise to entirely new forms of matter, or simply modify those that already exist? The implications are staggering, as they compel you to reevaluate your entire understanding of matter and energy. In an even more remarkable line of thinking, some theories propose a link between magnetars and the existence of gravitational waves. How could an object so distant be connected to phenomena observed in your own cosmic neighborhood? This possibility opens up a new frontier in astrophysics, where researchers are attempting to correlate these events to deepen your comprehension of the universe. Fluctuations in the behavior of magnetars have also fueled theories that they may interact with other cosmic forces in ways you don't yet grasp. Could they exert an influence on the expansion of the universe, or perhaps on gravity itself? These questions push you to investigate the very boundaries of physics and current understanding. As your exploration of magnetars deepens, you also encounter theories connecting them to the possibility of life on other planets, questioning if these extreme objects could affect the habitability of nearby star systems. Ultimately, the study of magnetars transcends a purely academic exercise. Each new theory challenges you to question and rethink your core beliefs about physics and the universe's nature. What other cosmic mysteries will you uncover as you continue to investigate these phenomena? The search for answers is a journey that is only just beginning, with each new discovery and evolving theory unlocking new pathways to knowledge. Human curiosity, the very spark that propels you to explore the unknown, remains vibrant in this field, guiding you toward a more profound awareness of your place in the universe. It is crucial to remember that every proposed theory is just one piece of a much larger, more intricate puzzle. While you may not yet have all the answers, the pursuit of truth about magnetars will continue to inspire and challenge you to discover what still lies hidden in the vastness of space. In conclusion, magnetars are far more than mere stars. They are cosmic vaults holding secrets that could unravel the complexities of the universe. As you delve deeper into their study, the connections to quantum physics become increasingly clear, and every discovery brings you closer to a more complete understanding of the fundamental nature of matter and energy. Who can say what other cosmic wonders await as you continue to explore these captivating phenomena? Furthermore, the activity of magnetars is connected to phenomena that can initially seem beyond our ability to grasp. The gamma-ray bursts they unleash are like colossal cosmic spectacles, and by analyzing them, you can uncover clues about the formation of elements and the dynamics of galaxies. It's remarkable to think that such a remote event could hold insights into how the very matter of our own world came to be. Magnetars also provide you with a unique portal into the distant past. The processes of their formation and evolution are deeply woven into the history of the universe. When you observe a magnetar, you are essentially gazing back through time, gaining a deeper understanding of how massive stars detonate and give rise to these magnetic titans. This connection through time serves as a powerful reminder that the universe is an ever-changing, dynamic system, where every star in the sky has its own unique story. So, what does all of this signify for humanity? The investigation of magnetars could be the key to unlocking some of the most profound mysteries in physics. For instance, how do subatomic particles behave when subjected to conditions of extreme gravity? By studying these objects, scientists are actively challenging and broadening our current theories, which brings you one step closer to grasping the fundamental laws that orchestrate our entire universe. Magnetars also educate you about the life and death of stars. Their life cycle, which ignites with a supernova explosion and culminates in their transformation, echoes the transient nature of existence itself. Contemplating these cosmic transitions allows you to draw parallels with your own life, where transformation is not only inevitable, but often essential for growth and evolution. Another captivating aspect of magnetars is how they might influence the birth of new stars. Their immensely powerful magnetic fields can disturb the surrounding clouds of gas and dust, potentially creating the perfect conditions for new stars to form. This presents a truly fascinating question. Could magnetars be catalysts in the grand stellar cycle, shaping the creation of subsequent generations of stars and, by extension, new planetary systems? And you cannot overlook the cultural impact these objects have had. Despite their immense distance, magnetars have fired our collective imagination, making appearances in works of science fiction and literature. Their depiction in these creative mediums not only highlights their visual wonder, but also encourages you to reflect on your own place in the cosmos, prompting thoughts about the potential for life on other worlds and the cosmic forces at play. As our technology progresses, the study of magnetars might also unveil new pathways to understanding energy and matter. You can just imagine a future where we could learn to harness the incredible energy of these cosmic giants for our own needs. While this idea may currently seem like science fiction, breakthroughs in physics could one day permit you to utilize cosmic forces that now feel entirely beyond our reach. Human curiosity is fundamentally tied to our desire for knowledge. The study of magnetars, while incredibly complex, compels you to question what you already know and to explore what remains undiscovered. Every new piece of information about these objects forces you to revise your understanding of the universe, and, in doing so, your understanding of yourself. Within this journey of discovery, international scientific collaboration plays a crucial part. The science of magnetars recognizes no borders, as research teams from all over the world join forces to decode the puzzles these celestial bodies pose. This unification of intellect is a potent reminder that despite the vast distances separating us, you share a common curiosity and a drive to comprehend your place in the cosmos. Ultimately, the study of magnetars carries implications that reach far beyond astrophysics. They teach you about resilience and the capacity to adapt. Just as a magnetar can arise from the cataclysmic explosion of a massive star, you too can discover strength in the face of adversity. Each lesson you learn from these cosmic behemoths can serve as an inspiration to overcome your own personal challenges. In the end, magnetars are much more than mere astronomical occurrences. They are cosmic guides that instruct you about life, the universe, and your own role within it. As you continue to explore and investigate these captivating objects, you are not only expanding your scientific frontiers, but also inching closer to a more profound understanding of your own existence in this immense and enigmatic cosmos. As we approach the end of this fascinating exploration into the world of magnetars, it is worthwhile to pause and consider what you have learned. What can these cosmic entities truly tell you about the universe you inhabit? They act like brilliant lighthouses in the cosmic dark, shedding light not only on their immediate surroundings, but also on your fundamental grasp of physics and astrophysics. With their extreme magnetic fields, magnetars defy our conventional understanding of matter. Have you ever considered how a magnetic field could become so intense that it can literally change the behavior of the material around it? Picture a magnet that doesn't just pull on small metal objects, but can actually affect the very structure of space. This is precisely what magnetars accomplish, and their study helps you comprehend the foundational forces that govern everything. The entire life of a magnetar, from its birth in a supernova to its eventual fade, represents a spectacular cosmic cycle. But what relevance does this hold for you? It serves as a reminder that the cosmos is a realm of perpetual change, a place where the death of one star can set the stage for the creation of new forms of matter, and perhaps even life. In this way, magnetars illustrate the deep interconnectedness of everything in the universe. When you discuss magnetars, you inevitably touch upon Einstein's theory of relativity. How is it possible for an object of such immense mass and density to profoundly influence the curvature of space-time? The pursuit of this answer takes you to the very limits of our knowledge and beckons you to contemplate what might lie beyond our current comprehension. Relativity is not just a theory, it is a gateway to new possibilities and discoveries. Moreover, the established connection between magnetars and gravitational waves demonstrates that these phenomena are not just fascinating in isolation. Instead, they serve as powerful instruments for probing the universe. By detecting the ripples in space-time these events create, you gain an entirely new sense with which to observe the cosmos, opening up revolutionary ways to explore its deepest secrets. What profound secrets might gravitational waves unlock for us down the line? This very question fuels the work of scientists, as every new magnetar observation brings you closer to solving the deepest enigmas of the cosmos. These observations are not just data points. They are potential keys to a more complete understanding of the universe's fundamental workings. Among the most fascinating characteristics of magnetars is their profound effect on the formation of stars. You might wonder how such an incredibly extreme object could possibly steer the birth of new suns and even entire galaxies. Essentially, magnetars act as cosmic sculptors, shaping the very stellar nurseries where new stars and planetary systems come into being, a relationship that is vital for grasping the long-term evolution of the universe. Our collective fascination with magnetars has also found its way into popular culture, bridging the gap between hard science and public imagination. Consider how many books or films you've encountered that were sparked by these celestial marvels. Science fiction frequently borrows from scientific breakthroughs, and magnetars serve as a prime illustration of how genuine scientific inquiry can ignite creative thought, helping to make abstract cosmic topics feel more immediate and relatable. Looking ahead, it's crucial to consider the cutting-edge research being planned for the study of magnetars. New technologies, including more powerful telescopes and dedicated space missions, are currently in development to observe these distant objects in greater detail. The capacity for new revelations about magnetars is immense, with researchers uncovering fresh data each year that deepens our comprehension of these powerful phenomena. Of course, the investigation of magnetars is far from straightforward, as researchers encounter substantial obstacles in their search for answers. The sheer distances separating you from these objects, combined with the inherently complex nature of the events they generate, means every new finding is hard-won. Yet it is precisely these difficulties that infuse the scientific process with its excitement and ultimate sense of reward. Quantum physics also enters the picture when trying to fully comprehend magnetars, particularly in how these cosmic behemoths align with the principles of quantum mechanics. As you delve into these connections, our understanding of the universe broadens, and each successive discovery paves the way for even more sophisticated theories and concepts, pushing the boundaries of what we thought was possible. Ultimately, it is worth reflecting on what the study of magnetars means for all of humanity. What lessons can they offer you about our own place within the vastness of the cosmos? Grasping the nature of magnetars is more than a purely academic pursuit. It is a profound investigation into our own existence and our connection to everything around us. It teaches us that while we may be insignificant in scale next to these stellar giants, our species is defined by its relentless curiosity and its capacity to learn. As this exploration draws to a close, it becomes evident that magnetars are far more than mere astronomical subjects. They are integral nodes in the intricate web of forces and events that construct our universe. The curiosity they spark in you is merely the start of a much longer voyage, one that promises to unveil even greater mysteries in the years to come. What other wonders lie waiting for us in the limitless expanse of space? Only the future holds the answer.